Here he is. There's the fish. They're doing well. I lost one the other day. One drowned. Where is it? Up there somewhere. I put some food in. It was too much. I put these big chunks of stuff. He must have choked the poor little thing. Anyway, it was a big one. He was years old, and they die after a couple of years anyway. Don't they, Trigger? You last a few more, eh? And me? Your eyes looking better. It's looking good. You know, the mice are good. Doing well. Anyway, take the voice off. I'm pulling this apart. Got this open. Look at the speaker. Look how shot that is. It's rusty. It's ripped. This one's alright. This one's good. It's only 10 watt, 4 ohm. So as long as you match those up, the wattage and the ohms usually are pretty good. So I'll find another 10 watt, 4 ohm one. See if I can find exactly the same model. ADA 10800 looks like. Can be more wattage. You can put in like a 20 watt, but it'll probably only operate up to 10 watts. So, or is it under? I'm trying to think. As long as it's the same ohms, I think it works. So you won't get much louder than 10 watts because it will draw that much power from the speaker. So if it's more, it'll work right. If it's a 5 watt speaker and your system's running, it can blow it, I think, blow the speaker. So if it's under the wattage, it might blow. It's over, I think it's all right. So it'll only draw so much power from that. That's what I did in my room. I got a 100 watt speaker on a 31 and it works fine because it's the same ohms, it's 8 ohms. So this one needs to come off. It is wrecked. There's a lot of rust in here. I don't know if it's worth salvaging. This looks good though, the tape deck. Looks in good work. That's all I really want is a tape deck. So I could even take this out and just, you know, somehow fashion a tape deck with speakers. But I'll see if this works. I'll clean it up. I'll take the rust off. If there's any components that are broken like this one, I'll just bust it off and put on a new one, solder in a new capacitor, find a new one. All this rust, I'm going to have to take these off and wash them completely. Give them a good soak in some oil and maybe some alcohol to sort of lubricate the rust off and then wash it off with the alcohol. The alcohol is more of just a cleaning agent for circuits because it's not, it dries very quickly and doesn't corrode. It sort of just washes everything off. So that's why I use alcohol. You'll find a lot of people use alcohol. Or they might just get a, you know, compressed air can and blow it over and then brush it off with a brush or something and maybe a bit of some kind of oil or something. Or you want stuff that's not conductive, so you wouldn't use water so much. I did soak this in water to wash it out, wash all the grit out initially, but look at this transformer, whatever it is down there. It's in such bad shape. But look, I could probably get new components if it's worth it. The chip looks in good shape, doesn't it? The Sanyo. It looks like not too bad. Some of these resistors look a bit rusty, but it looks bad on the surface. But as long as the points are alright, they haven't broken. Usually, you know, as long as they clean up, that they'll probably be alright. This got hit, and so did I hit another one. Not sure where it is. If it's in here, I think I dropped it. It'll be on the floor somewhere. I dropped it the other night. I don't know where it went, but I knocked the bowl off the table. The bowl had all my stuff in it. Anyway, it'll be around. I might even be able to find a schematic for this particular model and get the actual, you know, circuit design. I'll be able to fix it up from there. But this is basically just for me to learn how to build circuits. I want to know how different resistors affect different parts of the circuit and how to build them myself. And you know, you see these little things on test things, but when it comes down to it, these are just display units. So that's your display. These are kind of a display to tell you on or off, and these little switches, that's the on-off switch that clicks in and out. So you've got little switches here. These are your buttons for different selectors, sort of turn things on and off. So they're basically those. These are protection for voltage, really, so components don't get damaged, resistors. So say you got 5 volts going through all this. This is only 3 volts. Well, you put a resistor to bring the voltage down to a drop down to 3 volts. So That's what resistors are for voltage drop in case the components are lower than what your circuit voltage is. So that's what resistors are for. You'll put them before most of your components to drop the voltage, the positive voltage down. The earth wire doesn't matter so much, but it's the positive part that you got to worry about. These little bits, I don't know what that is. That looks like a little capacitor. That's a little ceramic one. That's an electrolytic, I think. That might even be a diode, or that might even be a little capacitor of some sort. Capacitors store up charge to sort of filter off your voltage, and you filter off your charges, your circuit. So they use as sort of filters and things. And say you only want DC off your AC, or you'll put that on with a a bio or whatever they're called. I can't think of it right now. Diodes and things. That might be a little diode there. That they tell the circuit to run a certain way. They'll have a negative charge and positive charge, and so it'll only run the one way. So if the circuit comes back the other way, if the voltage tries to go that way, it won't go that way. It'll come out negative and go back the other way, or however it works. Sort of got a little chemical that shuts down the connection when it tries to go the opposite way, so that the voltage will only run the one way. So that's basically it. You've got transistors. I don't know if there's any here. Transistors will, there's some. Here's some transistors. So they have a base emitter and a collector. So the collector comes in, your voltage, the emitter, the base will take some of the charge, and then the emitter will send out the result. And it kind of uses a switch, so when it gets up to a certain voltage, the transistor will switch off. It uses sort of a little gate switch sort of thing, kind of. These all seem pretty solid. That one looks like it's blown there. It's popped the cap at the top. That one looks alright. This one's a bit dodgy. I might end up replacing some of these if I can find them. They're only like 20 cents or $1 or a lot of the bits, and it might be good just to take that circuit off, unsolder it completely, and just work on it, then put it all back on. I think once the screws are off, have I got them all off? Might be another one. Or maybe I have to unclip these first, these ones. I think they just unclip. Some of them have little latches that click up and then you slide the thing out. Some just slip out. Other ones just click out. They're like a clicker, like that one. That was the speaker one that clicks out. That's your that's your headphone jack, I think. So that'll get a bit close to the speaker. These are your selector sliders for things. Bass and probably treble. So that's it basically. This one's probably a transformer circuit to boost the signal with a boost up the sound from your circuit voltage up to audible sound through your speakers. So we'll run through there. Yeah, there's not much else. It's just this little one that's bent, but maybe it's supposed to be. It looks like a fuse there, so I'll check that fuse. There's probably a speaker fuse. This one looks a bit better this side. It looks like this has been sitting in water over here, or in the rain on this side. Maybe it was on a window ledge or something. And this side looks okay. This is in better nick, sort of up to sort of halfway. The sort of halfway point, it's all rusty. So I'm not sure what's happened there. It was over at the tech school over there. There's a tech school, what do you call it, Polytechnic. And yeah, someone's chucked it in the bin, sort of, obviously it doesn't work. So I might just keep at it every day to see if I can do a bit more and see if we get some noise out of it. You never know. These clickers all seem pretty good. This one probably won't work. This latch at the bottom, see? This here, this will tell, this is a little, when you put your cassette in, it's got a little tablet there. So if that tab's missing, that'll slip in. And look, it takes the latch up. So that's why the record function won't work unless that tab's on. So if you got tape over it, it'll hold it on and protect. If you take it off, it'll slip in. See? Oh, sorry. If you have it on, it will push it down. But if you have it off, it will stay on like that and not work. So if you push it down, see, the record function clicks in. So I'll see if we can click it all the way down. See if it works. Still something stopping it. Might be some other mechanism. You have to have a tape in there for it to work. So I'll test it with a shitty old tape. I've got a blank one I could use. See if the recording works. I could test it on the blank one. I bought a blank one a while back. I just found some stuff at the op shop. It's hard to find tapes and that now, but there's a bit of a wire sticking out there. This little slider here is for the radio. Look, it's come loose. So when you dial the radio down here, it doesn't move across. So I can rejig that. I push it all the way this way and then pull that all the way down. Put it back on the rail. See if I can get it to click back in place and you can have the radio working. But yeah, it looks like a nice little tape deck back in the day. Good size. I do like double ones so you can dub tapes, but look, I'm not into it so much anymore. I had to buy a really long screwdriver to get down right, because this screw here, the access from the other side, and it has to go all the way through there. So yeah, I had to get that one. This one here is pretty easy. I'll be able to just, oh shit. A bit hard with one hand. Just to take the front off. I like pulling it all apart, seeing if everything's still okay. I did find one broken piece, which was like a screw mount. I'm not sure where it broke off from, but I'll find it. See if this will come all the way off. Yeah. So keep a tab on your screws. If you can, take photos of them and say, you know, this is for this is for that, or get a little box and label them, or a bit of sticky tape, put a label on it, say what they're for, so that way you don't lose things. That's just for this front cover, really, isn't it? That'll come off. I'll just check there's no dirt or anything in it. And anyway, I'll clean all this up and I'll get back to you in a while. I've still got the other parts over there. These parts here are cleaned up. So they should all work over there, I think, and the cover. It's mainly just replacing that speaker and getting the rust off these, see if any of these components are any good. The rest, except for the slider there, seem alright. The tape deck looks in pretty good nick. I don't know, but it clicks back. They look a bit forward there, don't they? But I think they'll push up a bit like that and straighten. Yeah, that's what I'm up to today. I've got to do some more, use my laptop there to do some more research into verilog and yeah, it's just instructions really for how to work gates on a chip. Like one of these has all gates in it and it tells the pins which are inputs and outputs and which to switch to on or off. So that's how verilog works. It'll work on a chip like a microprocessor and give instructions, and then from each of those pins you can say what they're for and how long they stay on or off for with a timer or a clock, or you maybe have a sequence, or the use of switches for switching things on and off. And it's not a code as such. You don't compile a code. You're more writing a machine language to put into the flash drive of your microcontroller. So it will tell the microcontroller what those different gates are on and off, when they're on and off, and what they're used for. So you can control little things. They're just switches, really. Gates, they're just gates, open or close, 1 or 0. So you can store information, or you can you know, operate a fan or a temperature gauge or whatever. So yeah, it's interesting. I'm learning about verilog. So yeah, you basically have a module, which is, this is kind of a module. You say this is your module, you give it a name, you say what the inputs and outputs you're using are, like pin 1 or pin 2 or X or Y, and then you just say you know, which gates they're for, the OR gate or the OR AND gate, which inputs and outputs belong to what. Then you write up a table, you know, maybe you might put a table in to say, you know, a truth table to say if 2 are on, then that's off, and if 1 is on or 1 is off, then that's an OR, that's on. And you put in your truth table how the OR gates work, and then you might, you know, set that up to set off a whole lot of functions, and you might return and do a return function to go back and do it again. So when it goes through again, it does something different. Might have a timer that goes back and then returns and then comes back and checks the temperature is at a certain temperature, which will be a voltage, and then as soon as that voltage is known, it'll go to another gate and say, okay, this is 3 volts. That means the fan comes on. So, the fan comes on when the heater gets up to 30 degrees, which is 2 volts or something. So yeah, little things like that to work fans and motors, and you can say speed of a motor is basically the velocity or speed or anything is a certain voltage. So if it's a high voltage, it'll be a high speed. High temperature will probably be a high voltage, or it can work the other way. It depends how you set it up. You might say at 100 degrees you switch off and it goes to 0 volts. You want your circuit to switch off at 100 degrees, so that's the limit. Like in your computer, you'll have your fans that come on at certain temperatures, or say your CPU gets up to 100 degrees, it'll switch off. That's basically what computers are. It's sets of instructions, and that codes are more for your programs, your programs, and then they relate to your certain more codes like verilog to tell what the certain switches and circuits do to switch on and off, more of a hardware level rather than software. So I suppose verilog is sort of instructions on a hardware level, not so much the software in a way. I suppose you use software to design it, then you push in your flash drive, runs your hardware, and then you plug in your contacts to whichever pins. But yeah, it's interesting. It all relates to everything, really. This has probably got some kind of flash verilog thing in it or something to say what that little chip does there. A Sanyo chip. It's probably got ands and ors and flip-flops and things in it. So they'll have little gates and things inside of them. That's what they are, So hope you learned something there. And you have a module, an end module. That's your right module. Then you give it a name. And then you put your inputs and I think your outputs. And then you put like what the outputs and inputs mean, where they belong in the chip. And then you say what they do and all that. That's how you do verilog. And then you put end module at the bottom to say finished. Then you might do a table, which is called something else. I can't think of it right now. And you can put your truth table in there, what all the gates do and what they mean and stuff like that. You can add that into your code in the middle somewhere or at the end, and it will relate to what you're doing. So it might turn on red lights at a certain time, or blue ones or green ones, or you might even have a little servo that drives your little tone thing. So if you hit a certain note on your music, it turns the tone down to 0 or something. There's all sorts of little machine things you can do. It's sort of like manual robotics in a way, because you're sort of manually doing it in a way, but in a way it's sort of it's like sort of I suppose if you set it all up, it's sort of like a robot in a way, isn't it? Because it's doing it all itself. But you're sort of programming its choices, what it will do at a certain time. But I suppose like us, we respond with our sensors, and these here, like a temperature sensor is like their eyes or the ears or the touch, or microphones like ears. It's similar to a human body, but it's totally different really in a way, because it's all sort of the way it is. I suppose we are in a way too, otherwise we'd blob around different shapes when we were sort of a human form, and our own little robotic sort of humanoid thing. But be interesting to see where it all goes. Anyway, I might have a cup of tea, and that's that. I'll clean this up.